see there. Okay, perfect, perfect. Okay, so if you're looking at a situation like this, right, we need to, as you said, right, the following sketch shows the graph of f of x and g of x. It's a sine graph and a cos graph. And then it says here where x is between -90 to +180. Now, the fortunate thing is it's easier to spot which one is a cos graph, which one is a sine graph. So if you look at what we have for f of x here,
Negative.
the equation is clearly showing you that you have a negative sine graph, of which, just because we know we have a negative sine graph, it's good enough for us to like work out which image is the sine graph. Because if it was a normal what you call sine graph, let's say it was y is equal to negative sine x, you would have had from 0 to 360 a graph that looks like this, right?
Yes.
Yeah. However, because now you can see here there's a specific value for frequency, it means in a space of 0 to 360, you don't have like one graph. So A here is not a 1. Luckily, we have an image here that is helping us to see which one is the sine graph. Because you can see from 0 to 180, you have one graph, meaning that our value of A there is technically a 2. Because in a space of 360, you're going to have had 2 of these instead of just one of them like that, you see. So just by looking at the image and just by looking at what we're given, we can already tell which one is the sine graph, because you can see here with the one that passes through D. I mean, yeah, this, if it were to be a sine graph that was not moved to the left or to the right, it has to pass through the origin, you see. So that's where you knowing what your sketch looks like and you knowing what your equation looks like, that's why those two things like work together.
Yeah.
So here you can already see it's a cos graph, a standard cos graph that was moved 30 degrees to the right. You see, 30 to right. Because if you know, a cos graph would have started off passing through, let's say here somewhere at 1. It would pass through the x-axis at 1, as long as it was not moved up or down or left or right. This is what a standard cos graph would look like. You see, if it was y is equal to cos x here, it would pass there at 1, come down all the way to 360. So you can already see on the left side, the image would have looked like this, you see. So when that whole image now has been moved to the left as we are seeing, then we should expect something like that. You see where the turning point is not there anymore. It's like somewhere 30 degrees to the right. So this, if you move it 30 degrees to the right, you can see that the turning point there, you see, is going to be where it is now, which would somewhat, let's say somewhere here will be like a 30, you see, of which that's how we can already see this is 30.
Yeah. So the cos graph doesn't usually start at 0. It starts everywhere else but 0.
No, the standard cos graph also, oh, you mean like passing the origin?
Yeah, like the 0 cuts through the 0.
So the standard cos graph, as you saw, when you look at it from 0 to 360, it usually cuts it, not usually, it will be showing you that it cuts the y-axis at 1. That's like the standard image, because remember we have said that with these trigonometric graphs, they are basically just periodic graphs. Periodic meaning they just go on forever and ever and ever and ever and ever, you see. But then depending on which portion of the image they show us, we will always see a very specific image, you see. So that's why we always say that as long as you know what your standard images look like from 0 to 360, you're then able to play around with them. Because with a sine graph, in as much as from 0 to 360 it looks like that, we still know that on the left side it will just do this going on and on. On the right side, it will still just carry on doing all that. See, so as long as you have an idea of what this portion of the image looks like, you can then, make judgments of what has happened to an original image. It's the reason why, if you move it, let's say 90 degrees to the left, right? If you move a coarse graph 90 degrees to the left, so if it looks like this, right? If you move it 90 degrees to the left, you can already see that this turning point here, right? It's at 90. But if you move the whole graph 90 degrees to the left, you're going to have your turning point over there, and then your picture would look something like that.
Okay.
You see, that's why a sine graph, when you have 90 degrees minus x, it's just going to be a cos graph. You see?
Yeah.
Yeah. So all that kind of thinking and all that is basically the reason why you want to just know what your standard image looks like. I mean, if we don't even complicate it, we could have just seen here sine x. If you plus a 90, you're still moving it to the left. It's still going to be cos x, you see, because if these were swapped around, you would be seeing sine 90 plus x, which is still just a positive cos x, you see, because if you
Yeah.
move the blue image to the right, this turning point would go over there, and then this part here, we know it would have just been extending like that, you see, because remember, it just goes on and on and on and on and on, all the way to wherever it's going to go to. So when this portion of the graph from this spot all the way until this spot, if you just picture it, you see, if you move it to the left 90 degrees, you would be seeing a cos graph from 0 to 360. That's why all this says all that it says. Cool.
Yeah. Cool.
So that deals with us knowing which equation is which without them telling us, but by them just showing us the images. As long as we know which equation is which, then these questions here, they are not going to be too crazy, especially from 1 to 5. So just stop this for now. Oh, what other wait? What? Yeah. So as I was saying, I think what's best to do now is, because we went through these in the last session, right? You can actually try these out. If
Yeah.
needs be. Yeah, just try and work out these questions. I mean, I could send you the PDF file from last week's session also, maybe, if you want to just refresh, so that you can see how similar these kinds of questions are. And then from there we can just move on from there.
Okay, that sounds good.
Cool beans. Cool beans.